Hello viewers, welcome to my channel AK Concepts of Electrical Engineering. Induced EMF in a rectangular coil. Considering a rectangular coil rotating on its axis having a length A and B. This coil is placed in uniform magnetic field. The flux density B is uniform. Axis is perpendicular to the field. Coil is rotating on its axis with constant velocity, that is omega radians per second. The EMF induced in the coil is maximum when the coil sides cut across the flux perpendicular, and no EMF is induced when the coil sides moves parallel to the field. The flux linking the coil at any instant is given by phi equals to surface integral of B dot ds, where ds is the normal component of the surface. Consider this in magnitude, that phi equals to s b ds cos theta, where theta is the angle between bs and ds. Theta can be replaced with omega t, so yes, b ds cos omega t. So phi equals to finally b cos omega t surface integral of ds. Surface integral of ds is equals to area of rectangular coil is given by length and a width into b, which equals to, let it be, s. The flux is given by b s cos omega t. We need to find out induced EMF E equals to minus d phi by dt. So E equals to minus d by dt of bs cos omega t. And we're going to get minus bs is the constant. Now cos omega t with respect to dt, you're going to get minus omega sine omega t. If you differentiate cos omega t, you're going to get minus sine omega t. Then here we have omega t. So if you differentiate omega t, you're going to get omega. So finally, induced EMF of a rectangular coil E is given by minus of minus plus. So B S omega sine omega t, where B is the flux density, S is the area, that is A cross B, and omega is the angular velocity. Let us solve one problem on this. That a square coil of side 20 is situated in uniform magnetic field with the axis normal to the field. If the coil is rotated with 1500 rpm about its central axis, find the maximum value of the induced EMF taking B equal to 0.5 Weber per meter square. So given B equals to 0.5 Weber per meter square, and the sides A equals to B, since it is a square coil, that equals to 20 centimeters or 0.2 meters. Speed n equals to 1500 rpm. We know B, and we need to find out the S omega. S in our problem is A into B, that equals to 0.2 into 0.2, which equals to 0.04 in meters square. Angular velocity we have given, that omega equals to, we need to find out 2 pi n, but n is in rotations per minute, but we need to find out rotations per second. So divided by 16. 25 rps. Now omega equals to 2 pi into 25, that is 50 pi radians per second. Finding E equals to B is 0.5 multiplied by S is 0.04 multiplied by omega is 50 pi and sine omega t. We need to find out the maximum EMF induced. So when this is maximum, which means sine omega t will be equals to 1. Then this final value will be 3.144 volts. So in our problem, we have only one single rectangular coil, or else number of turns is 1. Example, if number of turns is equals to 50, then what happens? Then this formula, induced EMF E equals to minus N d phi by dt. Then N, this value is minus d phi by dt is nothing but Bs omega. Then in that case, if number of turns in the coil is 50, then E equals to 15 to 3.144, which equals to 157.18 volts.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.